Decibels. Conversion of decibels and unitless ratio. Conversion of decibels and unitless ratio. When converting a power gain from units of bells or decibels to a unitless ratio, the mathematical inverse function of common logarithms is used, powers of 10 or the antilog. Converting decibels into unitless ratios for power gain is much the same, only a division factor of 10 is included in the exponent term. Example: power into an amplifier is 1 watt, the power out is 10 watts. Find the power gain in dB. Example: find the power gain ratio after ratio equals PO/PI for a 20 decibels power gain. Converting power gain to voltage/current gain. Because the bell is fundamentally a unit of power gain or loss in a system, voltage or current gains and losses don't convert to bells or dB in quite the same way. When using bells or decibels to express a gain other than power, be it voltage or current, we must perform the calculation in terms of how much power gain there would be for that amount of voltage or current gain. For a constant load impedance, a voltage or current gain of 2 equates to a power gain of 4 to 22. A voltage or current gain of 3 equates to a power gain of 9 to 32. If we multiply either voltage or current by a given factor, then the power gain incurred by that multiplication will be the square of that factor. This relates back to the forms of Joule's law, where power was calculated from either voltage or current, and resistance. Thus, when translating a voltage or current gain ratio into a respective gain in terms of the bell unit, we must include this exponent in the equations. The same exponent requirement holds true when expressing voltage or current gains in terms of decibels. However, thanks to another interesting property of logarithms, we can simplify these equations to eliminate the exponent by including the 2 as a multiplying factor for the logarithm function. In other words, instead of taking the logarithm of the square of the voltage or current gain, we just multiply the voltage or current gain's logarithm figure by 2, and the final result in bells or decibels will be the same. The process of converting voltage or current gains from bells or decibels into unitless ratios is much the same as it is for power gains. Here are the equations used for converting voltage or current gains in decibels into unitless ratios. While the bell is a unit naturally scaled for power, another logarithmic unit has been invented to directly express voltage or current gains/losses, and it is based on the natural logarithm rather than the common logarithm as bells and decibels are. Called the Nieper, its unit symbol is NP, though lowercase n may be encountered. For better or for worse, neither the Nieper nor its attenuated cousin, the Decibel, is popularly used as a unit in American engineering applications. Example: the voltage into a 600 ohms audio line amplifier is 10 mV. The voltage across a 600 ohms load is 1 V. Find the power gain in dB. Example: find the voltage gain ratio AV ratio equals VO/VI for a 20 decibels gain amplifier having a 50 ohms input and out impedance.